In this video we are going to discuss about the ASIC design flow. On completion of this topic, students will be able to identify the various application methods and application using HTL. So this table of contents, here we are going to see about the ASIC design flow, its specification, codings, test bench simulations and synthesis, pre-layout, timing, back annotation, post layout, logic verification and tape out. So what is ASIC? ASIC is nothing but the application specific integrated circuit which works by connecting existing the circuit blocks in new ways. It is very higher speed, less area, power consumption and more time to market. So normally this ASIC, as the name indicates, this ASIC is non-standard integrated circuit that is designed for specific use or application. So generally ASIC design will be undertaken for a product that has very large production, and also it contains very large part of the electronics needed for a single integrated circuits. Examples of this one are a chip of toy beer, the talks, and a chip for a satellite, a chip designed to handle the interface between the memory and the microprocessor, and the chip containing the microprocessor. So we can see the ASIC design flow here. So in this ASIC design flow you can see test bench, RTL logic. From that it is simulated and passed through the synthesis. So in the synthesis we are using the standard cell technology library. Next it is pre-layout using the analysis, and this post layout synthesis can be done in a such a way if there is any if there is any error, or it should be auto corrected, so logical errors can be corrected using the previous steps, and finally it is pre-layouted for the synthesis. And here it has the specification of test bench, RTL coding and specification. So the features and the functionalities are already defined. Chip planning is performed and the architecture and microarchitecture are derived here. And in the case of the RTL coding, this RTL codings are containing the micro architecture which converts the synthesizable RTL code containing logic families, and also this code can be written manually, which interconnect is customized, and also this defined spaces between the rows can be manufactured in a lead time also. And here this RTL coding is normally used in this either by systematic approach or it has the guidelines. Also this can be a process of converting the RTL code into a gate level netlist. Also it vendors the cell library of basic gates. So here pre-synthesis can be also done in the IP core blocks. So this can be used in the major things of RTL behavioral and the structural simulation. So RTL coding in the behavioral coding is used to describe the black box design, where the output of the design is specified for a certain input pattern, and in the case of the structural pattern, this can be defined the different components and their interconnects present in the same design. So here we can design using some tools or structural patterns. Test bench and simulation. So in the test bench, first we are creating and simulating an RTL code using the HTL simulators. Using that we are using the Cadence or Verilog Excel. Mentor graphics modism are used here. Finally it is logically corrected, and during the synthesis it is converted in the optimized logical gate level, and then this synthesis tools like synopsis design compiler is used, and it is auto corrected. So here the synthesized database along with the timing information is given, so that it determines the data and finally it can correct it automatically. Based on the timing calculation, layout is produced, and also it synthesizes the database together with the timing information from one place to the logic gates, and it has a timing critical path. The back annotation is the process where the extraction of the RC parasites are made on the layout, and this path delay is calculated from these RC parasites, and the back annotation is the step which bridge the synthesis and physical layout. In the post layout timing analysis, it allows real timing violations such as hold and setup. Also this is fed into the timing analysis, and then setup violation is fixed. The logic verification, the final check is made and it is design is correct functionally after additional timing, and also this is reassembled using the test benches. If there is any failures, it moves to the step by step rate. And tap out, when the design passes the logical verification, it is ready for fabrication, and it is in the form of GDSI file which is accepted on the boundary. Quiz questions on Asic design flow. When NMOS gate is connected to positive channel is formed, starts to conduct, starts to burn, none of this. Thank you.